Welcome to our introductory video about ALAB. But before we talk about ALAB, let me tell you a bit about LaTeX. LaTeX is a document preparation system which is widely used in academia for the publication of technical and scientific documents. LaTeX allows the author to focus on the content and takes care of the formatting and layout of the documents itself. One of the main reasons behind popularity of LaTeX in academia and scientific community is the simplicity it offers while constructing even complex math equations. Unfortunately, all the existing LaTeX editors are either partially accessible or completely inaccessible, and that is due to the inability of screen readers to read mathematical expressions. So, with the collective effort of Ignite and LUMS, we developed ALAB, which is an accessible LaTeX editor with special focus on math. Predictably, our editor will offer visually impaired people enough autonomy that they will be able to write, edit, and understand both basic and complex mathematical equations. The three major features of ALAB are debugging, mass mode, and PDF accessibility. Debugging supports navigation to the start of erroneous line. Mass mode offers support for basic and advanced mathematical LaTeX commands, and accessible PDF mechanically tags mathematical content to facilitate its correct narration by mainstream screen readers like JAWS and NVDA. Now let's see a demo of all of these features. I'll run the application, wait for it to load, I'll create a new project,
Enter project name. E. G. E. O.
name it and hit finish.
Build started. No error found. There is just one section and two, doc, empty line, begin opening curly bracket document closing curly bracket.
It provides consistent speech feedback
Empty
upon
line.
change of line.
Begin opening curly bracket document closing curly bracket. Empty line. Document class opening curly bracket article closing curly bracket.
Along with speed control, ALAB offers different levels of verbosity.
TDS is disabled.
Users can enable or disable TTS.
TDS is enabled. This is a very basic article template. There is just one section and two subsections. Document class opening curly bracket article closing curly bracket. Begin opening curly bracket document close. Empty line. Cursor mode enabled. Verbosity level changed to character. $. R. A. C. Opening curly bracket, 1. Closing curly bracket, opening curly bracket, 2. Closing curly bracket, $, space. Build start. No error found.
Now we'll generate an error
$,
and see
closing
how ALAB
curly
responds.
bracket. Build start. Empty line. Missing $, inserted. At line number 19. /DOCUMENTCLASS opening brace ARTICLE closing brace. Build started. Empty line. Missing $, inserted. At line number 19. $frac opening brace 1 closing brace opening brace 2 closing brace. Build started. No error found. $, caps S, %sign T, S, U, M, M, A, T, N, underscore, opening curly bracket, N, is equal, 1, closing curly bracket, F, open parenthesis, X, build started, space, undefined control sequence, either misspelled or missing package $\summation, followed by, underscore opening curly bracket on equals 1 closing curly bracket, X, $frac opening brace 1 closing brace opening brace 2 there's a closing curly bracket missing, unexpected end of file at line number 18. Empty line. $t slash, there's a closing curly bracket missing, empty line. Pair, missing $, undefined control sequence, either misspelled or missing package $summation, followed by, underscore opening curly bracket on equals 1 closing curly bracket, x, at line number 20. Missing $inserted. Paragraph ended before over was complete. There's a closing curly bracket missing, unexpected end of file. Undefined control sequence, either. There's a closing curly bracket missing, unexpected end of file. There's a closing curly bracket missing, unexpected end of file at line number 18. Build started. Undefined control sequence, either misspelled or missing package $summation, followed by, underscore opening curly bracket on equals 1 closing curly bracket, x, at line number. Build started. No error found. Verbosity level changed to word. Empty line. Empty line. This is a debug demo. Empty line. This is a debug demo. This is a debug demo. Empty line. Verbosity level changed to character. Caps T. T. H. I. S. Space. I. S. A. G. E. M. O. THISISADEBUGDEMO. THISISADEBUGDEMO. Space. 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 Verbosity level changed to word. A. Debug.
So this was the debugging feature of ALAP. Automatic redirection, multiple verbosity level, and ability to toggle between the auditory feedback of errors really facilitate blind users as it intuitively guides them about potential errors. Now we'll talk about another feature of ALAP called Math Mode. Math Mode narrates the generated PDF in a concise yet descriptive form, but with an extra focus towards mathematical content. As you can see, we have fraction and summation in our PDF. ALAP will attempt to narrate it as likely as a human would. Let's see how ALAP will pronounce this PDF document.
Empty line. Build started. No error found. Title. Subtitle. Plain text dot. Another subtitle. More plain text dot. Fraction numerator 1. Over denominator 2. and frac. Summation underscore n is equal to 1. And sub. F open parenthesis x close parenthesis. This is a debug demo. This is a debug demo.
For the ease of users, MathMod has a shortcut key, caps plus T.
Title. Subtitle. Plain text dot. Another sub.
So now I have pasted bunch of complex math equations on the editor. Let's see how our generated PDF looks. So it might appear a bit unaligned to you, but this is completely intentional. And that's because LaTeX offers multiple inline and display delimiters, which then renders equations differently on PDF. And hence, to display the wide scope of ALAP, we've used multiple delimiters in this video sample. As you can see, we have used backslash square bracket, backslash open parenthesis, single dollar, double dollar, begin equation, and a few more. So if you can see the PDF, you see that at the top we have a 3 by 3 matrix that has a bunch of fractions as its element, and then we have a nested fraction equation. Below this we have an equation that contains bunch of set and logic related notation. And then we have around 6 hybrid equations that contain different combinations of square roots, derivatives, partial derivatives, integrals, and fractions. Now all these equations are somewhat complex due to their nested nature, so it will be interesting to see that how accurately and how successfully ALAP conveys their structure to the listener. Now let's see how ALAP will narrate these equations.
M is equal to start of matrix opening bracket. 3 by 3. Fraction numerator 5. Over denominator 6. And frac. Fraction numerator 1. Over denominator 6. And frac. 0. Fraction numerator 5. Over denominator 6. And frac. 0. Fraction numerator 1. Over denominator 6. And frac. 0. Fraction numerator 5. Over denominator 6. And frac. Fraction numerator 1. Over denominator 6. And frac. Fraction numerator 1. Over denominator 6. And frac. Closing bracket end of matrix. Fraction numerator 1 plus. Fraction numerator A. Over denominator B. And frac. Over denominator 1 plus. Fraction numerator 1. Over denominator 1 plus. Fraction numerator 1. Over denominator A. And frac. And frac. And frac. For all x is an element of z, there exists y is less than n equal to epsilon, summation underscore n is equal to fraction numerator 1. Over denominator 2. And frac. And sub. Raised to power infinity. And power. Sine theta raised to power 2. And power. Plus cosine open parenthesis theta close parenthesis raised to power 2. And power. S is equal to square root inside radical. Fraction numerator 1. Over denominator n minus 1. And frac. Summation underscore I is equal to 1. And sub. Raised to power n. And power. Open parenthesis x underscore I. And sub. Minus over line x close parenthesis raised to power 2. And power. And radical. Fraction numerator integral ellipses integral underscore minus infinity. And sub. Raised to power infinity. And power. Sin h open parenthesis x close parenthesis over denominator square root inside radical. A plus b. And radical. And frac. Fraction numerator partial y. Over denominator partial x. And frac. Fraction numerator d raised to power 2. And power. Y. Over denominator dx raised to power 2. And power. And frac. D open parenthesis pq close parenthesis is equal to square root inside radical. Summation underscore I is equal to 1. And sub. Raised to power n. And power. Open parenthesis p underscore I. And sub. Minus q underscore I. And sub. Close parenthesis raised to power 2. And power. And radical. And degree partial derivative q with respect to t is equal to g degree partial derivative s with respect to t.
ALAB tells the user about start of matrix, size of matrix, and then it goes on to narrate the matrix row by row. But you must have observed a slight pause every time the row changes. That is to indicate the end of current row and start of new row. ALAB also explicitly specifies the start and end of every fraction, root, power, and underscore. This feature enables blind users to comprehend even complex and nested math equations. Finally, we'll talk about accessible PDF. This feature, as I already explained, mechanically tags mathematical content to facilitate its correct narration by mainstream screen reader like JAWS and VDA. Can be turned on by clicking this button. Now let's see how our generated PDF looks. So it has a bunch of equations and we'll see how JAWS narrates an untagged PDF.
PDF-Adobe Acrobat Reader DC document. E. X2 plus 1. X. Y X2. Y. P1. N equals 1 and 2. A Q. And T equals an S. A T.
This narration wasn't even remotely close to the original mass content. It skipped symbols, misread structure, and was unable to convey a clear description to its listener. Now let's see how JAWS narrate a tagged PDF generated using ALAB.
Tag PDF.pdf. Square root inside radical x raised to power 2 n power plus 1 n radical. Fraction numerator x over denominator y n frac is greater than and equal to fraction numerator x raised to power 2 n power over denominator y n frac. Summation underscore n is equal to 1 n sub raised to power infinity n power n raised to power 2 n power. Partial derivative q with respect to t is equal to partial derivative s with respect to t.
As you can see, the narration was refined, meaningful, and concise. The advantage of this feature is that in case of unavailability of ALAB, user can still understand math equations in the PDF file by using existing screen readers. This feature will also notify the user if there exists a potential violation of PDF accessibility standards as per defined by WSAC 2.0 guidelines. Moving on, we also conducted a workshop. This workshop was conducted with a diverse set of participants and it lasted around 1.5 weeks. During this workshop, visually impaired individuals were familiarized with ALAB and LaTeX. Workshop was mainly divided into two major halves. First half was introducing LaTeX and an existing LaTeX editor to the participants, and second half was acquainting participants with ALAB. A research paper about ALAB was accepted in the 2018 ESSETS conference. We've also submitted a paper in the upcoming CHI conference, and a journal paper is in pipeline as well. Dr. Asim Karim and Dr. Suleiman Shahid closely supervised this whole project and directed their team to design a product that would bridge the technology gap for visually impaired individuals and will be a fundamental step towards building more accessible and inclusive academic tools. We sincerely hope that as a result of our efforts, blind individuals will be more independent and motivated to work in LaTeX, math, and pursue technical subjects. Thank you very much.